So we have discussed what acids, bases and salts are. You all know about indicators, the litmus paper, phenolphthalein, methyl orange and pH scale, and also you all are familiar with the neutralization reaction. So now we are going to discuss the exercise from your grade 11 textbook, that is unit 7. So the first question, complete the following sentences. So you have to answer these questions. So I am sure you would have already answered the questions. If not, you all can answer the question first and by yourself first and then listen to my discussion. So the first one, complete the following sentences. Sodium hydroxide and acid react to form sodium chloride and water. So to get sodium chloride, the acid should be hydrochloric acid. Hydrochloric acid. So sodium hydroxide and hydrochloric acid react to form sodium chloride and water. You can remember the reaction. Sodium and chloride combine to form sodium chloride. H plus and OH minus combine to form water. Then calcium carbonate and hydrochloric acid react, liberating. You can remember acid react with carbonates and bicarbonates to liberate carbon dioxide gas, CO2 gas, or you can write it as carbon dioxide gas. Potassium hydroxide and sulfuric acid react to form what? Potassium and sulfuric acid. So it will become potassium sulfate and water. So here it has to be potassium sulfate and water. Then we have acid and hydroxide react giving magnesium nitrate. So to get nitrate, what should be the acid? It should be nitric acid. Nitric acid and magnesium hydroxide. Hydroxide react giving magnesium nitrate. Then we have acid reacts with magnesium liberating gas and forming the salt. So it will be hydrochloric acid. Hydrochloric acid. Acid reacts with magnesium liberating hydrogen gas and forming the salt magnesium chloride. Okay students, so you can fill in these blanks in this manner just by looking at the sentence. If you immediately understand the reaction, then directly you can fill the blanks. If it's difficult for you, I am sure most of you all are capable of filling it like this, but if you find it difficult, then what you can do is you can write down the reactions. Now for the first one, if you say sodium hydroxide and hydrochloric acid react to form sodium chloride and water. So you know the base is sodium hydroxide. We don't know what the acid is, but you know the products are sodium chloride and water. So you know sodium comes from here, sodium, OH for water. So we need to have hydrogen for acid plus this Cl comes from this. So then you know this is hydrochloric acid. So sodium hydroxide and hydrochloric acid react to form sodium chloride and water. Then the next one, you can see calcium carbonate and hydrochloric acid, when they react, you know the reaction, calcium chloride plus water plus CO2 gas. So that is something you all should remember also. Acids reacts with carbonates and bicarbonates to evolve carbon dioxide. So from this also you can find the gas. Then potassium hydroxide and sulfuric acid, the next one. The third one, potassium hydroxide and sulfuric acid, H2SO4. When they react, you know it has to be K2SO4 plus water. You all are familiar with all these reactions. So they produce potassium sulfate and water. Is that okay? So the fourth one, it was blank, acid and dash hydroxide react giving magnesium nitrate. So we only know that the product is magnesium nitrate, MgNO3 twice, and you know for sure there is water produced. Then you can write the base and the acid. Why? Magnesium has to be in the form of hydroxide, MgOH twice, plus the nitrate has to come from the acid, HNO3. Earlier also I told you all these are double displacement reactions. So now you know this is magnesium hydroxide and HNO3. So nitric acid, HNO3 is nitric acid and magnesium hydroxide react giving magnesium nitrate. And the last one, hydrochloric acid, that we don't know, reacts with magnesium. So you don't know what the acid is, but we know it reacts with magnesium, liberating hydrogen gas and forming, that also we don't know. But we know it is a salt of magnesium. This, of course, you have to remember the reactions that we did in the lab. It can be other acids also, but you can remember with dilute hydrochloric acid. So because of that, we use HCl here. Dilute hydrochloric acid with magnesium gives H2 and magnesium chloride. So that is how you write the answers and fill in the spaces. Is it clear to you all now? By reading the sentence, if you can remember the reactions, it is very good. But if you can't do that, then you can write the equations and then find the answers. Either way, it's correct as long as you can do it correctly. So did all of you all get these correctly? I'm sure you were able to do it. So then I will move on to the next question. You are provided with 3 unlabeled solutions of, so what are the solutions? Sodium hydroxide, you know it is NaOH, then dilute hydrochloric acid, uric acid, HCl, like I have told you all before, when you read the question, if you can note down the important points, it's easy, and sodium chloride. So sodium chloride, NaCl. Here, since you all are practicing, I am writing down everything. You can just write down only the chemical formula. So you can see one is a base, the other one is an acid, and the last one is a salt. You are given only blue litmus. So we have only blue litmus. So these you can see unlabeled solution. That is the important thing. And you are given only blue litmus papers. Using only them, how do you identify the above 3 solutions? So you have to say how you can identify. Now there are 3 solutions. This is the question. You have the blue litmus, you have NaOH, you have HCl, and you have NaCl. But you don't know what is what. You know sodium hydroxide is a base. So the base litmus color is blue. There will be no change. Hydrochloric acid will turn blue litmus to red. Again sodium chloride, there will be no change. So what do we do? Let's say, now only I am going to give you the method. Let's say we label the containers as A, B and C and take the solutions into A, B and C. To this you put a strip of blue litmus into each solution. Like we did before, you put a strip of each blue litmus, one into this and one into that, and you observe the color change. So let's say in B, or let's say, alright, in B, blue litmus becomes red and A and C remain blue. So from that, if this was the observation, it can be in another one also. I am just assuming that in B, the blue litmus became red. So from that, what can you conclude? You can conclude that this is hydrochloric acid, HCl solution. Is that clear? Right. So now we know B is HCl, but we don't know what A and C are. We have only blue litmus. But when you put the blue litmus into HCl, what happens to the litmus paper? It turns red. So now you have a red litmus paper as well. So what can you do? You can take that red litmus from here, take red colored litmus from B, tear it into 2 pieces. Then what can you do? Put one piece into A and C. Put one piece each into A and C. Then what will happen? Let's say in A, the red litmus becomes blue. So here again we have another observation. In A, red litmus turns blue. So that means it is sodium hydroxide. So now we have confirmed that B is hydrochloric acid, then A is NaOH. So what is left? We have sodium chloride. Is that clear to you all? Take the solution separately into 3 containers, label them as A, B, C. Then to each solution put a strip of blue litmus. in one solution, the blue litmus will turn red. That is hydrochloric acid. Here I have taken that as solution B. Then you take out that litmus paper without making it into a chunk. You have to just tear it into two pieces and put each of those pieces into A and C. Inside A, if the red litmus becomes blue, that means that solution is NaOH. What will happen inside C? The blue litmus will remain blue, red litmus will remain red. That means it's a neutral solution. So that is sodium chloride. Is that clear to you all? That is how we can identify three unlabeled solutions which contain sodium hydroxide, hydrochloric acid and sodium chloride. With that, I will move on to the next question. Fill in the blanks with the solutions selected from the following list of solutions. So, you are given some solutions here. You can see, students. Sulfuric acid H2SO4 aqueous, hydrochloric acid HCl aqueous, ammonia is NH3 aqueous, H2O liquid is water, calcium hydroxide aqueous is CaOH twice aqueous, then CH3COOH aqueous is acetic acid. So here the two substances that turn red litmus to blue. Red litmus to blue means they have to be bases. Can you find the bases from there? Ammonia aqueous and calcium hydroxide aqueous. NH3 aqueous and calcium hydroxide aqueous. Turn red litmus to blue. Then the two act as strong acids. What are the strong acids from here? You can see H2SO4 aqueous and HCl, hydrochloric acid aqueous, act as strong acids. Then in the two, pH is greater than 7. If pH is greater than 7, again they have to be bases. So we have already identified the bases. NH3 aqueous and calcium hydroxide aqueous. Vinegar used at home is diluted acetic acid. We have discussed this before. Vinegar is dilute acetic acid. So, diluted CH3COOH aqueous. Then the next one, causes severe burns in the skin when spilled. What causes severe burns? Sulfuric acid. Usually the acids are corrosive, and out of that you all can remember sulfuric acid is very corrosive and they can cause severe burns. So we can say sulfuric acid H2SO4 aqueous causes severe burns in the skin when spilled. Sulfuric acid also has the dehydrating ability. So it can be very, very harmful. Calcium sulfate salt is formed by the reaction between calcium sulfate. So we need to get calcium. So it has to be calcium hydroxide. Calcium hydroxide aqueous. And to get sulfate, we have sulfuric acid here. So it has to be H2SO4 aqueous. So are these correct? I am sure they are. Yes. And you would have got them correctly. Ammonia aqueous and calcium hydroxide aqueous turn red litmus blue because they are bases. Sulfuric acid and hydrochloric acid act as strong acids. Here they have given another acid, that is acetic acid, but that you know is a weak acid. Then in ammonia aqueous and calcium hydroxide aqueous, pH is greater than 7 because they are bases. Vinegar used at home is dilute acetic acid. Sulfuric acid causes severe burns in the skin when spilled, and calcium sulfate salt is formed by the reaction between calcium hydroxide aqueous and sulfuric acid. So with that, I will move on to the next question. Arrange the following solutions in the ascending order of pH. Ascending means increasing. So from 0 to 14, the acidity decreases, basicity increases. That is how you have to arrange them. Sodium hydroxide, strong base. Sulfuric acid, strong acid. Water, neutral. And vinegar is a weak acid. So what should you have first? You have to have sulfuric acid first. Acid. Then the pH will be ascending order. So it will be vinegar. Then we can have water. And then sodium hydroxide. Sodium hydroxide. You can see the pH increasing. Sulfuric acid, vinegar, water and sodium hydroxide. Then the next one. Of the solutions, dilute hydrochloric acid, dilute sodium hydroxide and acetic acid, which does not react with sodium carbonate. You know carbonates, that is sodium carbonate, can react with acids evolving carbon dioxide. So here the question is which does not react with sodium carbonate. Hydrochloric acid, yes. Dilute sodium hydroxide doesn't. Acetic acid also, yes. So the answer has to be dilute sodium hydroxide. Then we have the last question here. When somebody comes into contact with the plant Caja ambiliar, it causes itching and a severe burning sensation due to formic acid it contains. Formic acid. Suggest a suitable substance to apply on the skin to relieve that sensation. What can you apply? You can remember. Baking soda. What is baking soda? Sodium bicarbonate. You can use baking soda. Baking soda. Within brackets I will write the chemical formula also. NaHCO3, or you can use quicklime. You can remember that as well. Quicklime. That is calcium oxide. These are usually available in the household. So you can use one of these substances. Because this particular plant has formic acid. So acid has to be neutralized by a weak base. It has to be a weak base. You have to remember that, students. So baking soda, sodium bicarbonate, or quick lime, that is calcium oxide. You can use one of these. So students, with that I have completed the questions given in your textbook. Now I will be discussing some extra questions with you all. Extra question 1. Select the most suitable answer. So you are very familiar with these types of questions. Select the basic substance from below. It has to be a base. Lime juice, acid. Tamarind, I told you all, it's acid. And lime, what is the difference? Lime juice is citric acid. Lime is calcium carbonate, limestone, that is a base. Salt is not a base. It's usually neutral. When we say salt, we refer to the table salt that we use at home, sodium chloride. So that's neutral. So here basic substance, it has to be lime. Because lime juice, citric acid, tamarind is also acid, lime is calcium carbonate, and salt is sodium chloride. So then the answer is lime. Then acidic substance given below. again salt, sodium chloride. Then this is sodium chloride. What is caustic soda? Caustic soda is sodium hydroxide. That is a base. Milk of magnesia, magnesium hydroxide. And vinegar is acetic acid. So that is the acid there. Vinegar is acetic acid. Acetic acid also you all know, CH3 COOH. So I am writing all these, students, so that you can recall what we have already discussed before. When you are answering questions, you don't have to write everything, but it's better to recall all these information. Then if we move on to the next one, set of substances that are neutral. Lime again is basic. Copper sulfate, salt. Salt is sodium chloride. Both are salts, neutral. Then vinegar is acid. So that's not the answer. Lime juice, again acid. Salt is sodium chloride, neutral. Then orange juice, acid, and sugar is neutral. So here you can see they have asked for the neutral substances. Soap is basic. Jeevani contains salts. Saline contains salts. Vinegar is acidic. So that's also not the answer. Then saline, condis, sugar, copper sulfate. Saline is salt neutral. Condis is potassium permanganate. That is also neutral. Condis is potassium permanganate. Then sugar is neutral. Copper sulfate is salt. That is also neutral. So that is the answer that contains the neutral substances. Select the true statement from below. First one, salt solution is neutral. So here again when they say salt solution, they mean the sodium chloride. That is the common salt. That is neutral. That is correct. Vinegar is a basic solution. That's wrong because vinegar is a acid. Then sulfuric acid is a weak acid. That's wrong. Sulfuric acid is a strong acid. Limestone is a strong base. No. Calcium carbonate is a weak basic substance. So the correct one is salt solution is neutral. So then I'll move on to the next one. Not an example of weak acids. Acetic acid is a weak acid. Hydrochloric acid is a strong acid. Citric acid, weak acid because it's in lime juice. Carbonic acid, weak acid. So the answer is hydrochloric acid. Then the next one. Select the false statement from below. False statement. Substances that release H+ ions in aqueous solutions are known as acids. That's correct. Substances that release OH- ions in aqueous solutions are known as bases. That is also correct. Hydroxyl ions. Hydroxide is formed during the reaction of an acid with a base. No. Hydroxide is present in a base. When a base dissociates, dissolves in water, hydroxide ions are released. So the base itself is hydroxide, sodium hydroxide. Acid and bases show different colors with indicators. So that is also correct. That means select the false statement from below. False statement is the third statement. I am sure you were also able to answer these correctly. I will move on to the next one. Acid used to coagulate rubber latex. What is the acid used to coagulate rubber latex? You all know it is acetic acid. So first one given is sulfuric acid. Second one acetic acid. Third one sodium hydroxide, that's a base. And fourth one copper sulfate, that's a salt. So it has to be acetic acid. Then substances that produce CO2 gas with carbonates and bicarbonates are what? They are acids. Bases no, salts no, acids not neutral substances. With that, I'll move on to the next question. What is the substance that release H+ ions in aqueous medium by incomplete ionization? So incomplete ionization means it has to be a weak acid. It has to be a weak acid. What is HNO3? It's a strong acid. NH4OH is a weak base. H3PO4 is a weak acid. Sodium chloride is a salt. So, H3PO4 is the answer. What is the substance that release H plus ions in aqueous medium by incomplete ionization? Phosphoric acid, H3PO4. Then what is not a property of salt? Not a property of salt. It has a high melting point, correct. They are crystalline in nature, correct. They are solids at room temperature, that is also correct. Most of them do not dissolve well in water. That is of course wrong. Most of them dissolve well in water. That is what we discussed with salt. So those are the questions. Then I will move on to the extra question 2. What is an acid? What is an acid? A substance that releases H plus ions in aqueous medium. Substance that releases H plus ions in aqueous medium. So, substance that releases H plus ions in aqueous medium is an acid. So, what is an acid? If you write this, it's fine. Write some examples of acids present in the school laboratory. So, you know the acids. You can write the name or the chemical formulae. I will write both here. So, you can write hydrochloric acid, hydrochloric acid, that is HCl. Then you can write sulfuric acid, H2SO4. Then you can write nitric acid, that is HNO3. You can also write acetic acid. We do have acetic acid in the lab. CH3COOH. So, write some examples of acids present in the school laboratory. Hydrochloric acid, HCl. Sulfuric acid, H2SO4. Nitric acid, HNO3. And acetic acid, CH3COOH. So, you can write all these. I am sure you also did it. Then with that, I will move on to the next one. Write the 2 types of acids based on their ability to release H plus ions in aqueous solution. What are those? Strong acid and weak acid. Strong acid, weak acid. I'm sure it's very easy for you all. Then the next one. What is a strong acid? What is a strong acid? Acids that release H plus ions in aqueous medium by complete ionization or complete dissociation. So, that is what you have to write here. Acids that completely ionize in aqueous medium. So, acids that completely ionize in aqueous medium to release H plus ions. When you say acid, it's understood that they release H plus ions. Or you can say medium to release H plus ion. So then the answer is even more complete. Write the equation for the dissociation of a strong acid in aqueous solution. So you all know many strong acids. You can write HCl hydrochloric acid, H2SO4 sulfuric acid and HNO3 nitric acid. I will write for nitric acid, HNO3 aqueous dissociates to form H plus aqueous and NO3 minus aqueous. Always H becomes H plus, the rest of the species becomes the negative ion, nitrate ion. Nitric acid forms H plus ions and nitrate ions. Then the next question. Write 3 examples of strong acids with their chemical formulae. 3 examples of strong acids. So, hydrochloric acid, chloric acid, HCl with their chemical formulae. Then we have sulfuric acid, H2SO4 and nitric acid, HNO3. So, hydrochloric acid, sulfuric acid and nitric acid. 3 examples of strong acids with their chemical formulae. So, I am sure you were also able to write all these. With that, I will move on to the next one. Extra question 4. What is a weak acid? An acid that ionizes incompletely or partially ionizes to give H plus ions in the aqueous medium. So, here substances that incompletely, you can use the word incompletely or partially incompletely dissociate to release H plus ions in aqueous medium. So, substances that incompletely dissociate to release H plus ions in the aqueous medium. So, here instead of incomplete you can say partial, instead of dissociate you can say ionize. All these terms are correct. Then write examples for weak acids. What are the weak acids you all know? Acetic acid, carbonic acid and citric acid, even phosphoric acid. So, you can write any. Acetic acid, carbonic acid, phosphoric acid, then citric acid. Citric acid in citrus fruits. You can also write ascorbic acid in vitamin C. I have mentioned that to you all before. So, these are some examples of weak acids. With that, I will move on to the next one. Extra question 5. Write 2 properties of acids. 2 properties of acids. What can you write? They are corrosive in nature. They turn blue litmus to red. They evolve hydrogen gas on reacting with metals above hydrogen in the activity series. They release carbon dioxide gas when reacting with carbonates and bicarbonates. You can write any 2 properties. So, write 2 properties of acids. So I will say turn blue litmus to red. Then evolves, or we can say react with carbonates and bicarbonate and evolve CO2 gas, carbon dioxide gas. So they want you to write two properties of acid. You can write any two. Write two uses of hydrochloric acid. What are the uses of hydrochloric acid? You can remember to remove rust from steel objects, then to extract gelatin from bony materials, and also to make aqua regia, royal water. You can write any two uses. So I will say remove rust from steel objects and to make aqua regia. Write two uses of acetic acid. What are the uses of acetic acid? You all know acetic acid is present in vinegar. Then to coagulate rubber, we can use acetic acid. Also, acetic acid can be used in the paper industry and also to produce synthetic thread. So, we can write any two uses. So, I will say used as vinegar, in food and to coagulate rubber latex. So that also we can use acetic acid. So those are two uses of acetic acid. With that, I will move on to the next question. What is a base? What is a base? A substance that increases the hydroxyl ion concentration of an aqueous medium. So here a base is a substance that increases the hydroxyl, that is OH minus, ion concentration of the aqueous medium. Write some examples of bases present in the school laboratory. You are familiar with the bases in the school laboratory. What are those? We have sodium hydroxide, that is NaOH, sodium hydroxide. So here again students, for you all to recall and remember, I am writing both the formula and the name. You all can write only one of the two. Then we have KOH, potassium hydroxide, we have CaOH twice, calcium hydroxide. So these are all different types of bases that are present in the school laboratory. With that, I will move on to the next one. Extra question 7. What is a strong base? You all know what a strong base is. Substances that ionize completely or dissociate completely in aqueous medium and increase the concentration of hydroxyl ions. So those are strong bases. That is what you have to write here. So a substance that dissociates completely and increases the hydroxyl ion, that is OH, concentration of the medium. So that is a strong base. Then the next question. Write the equation for the dissociation of a strong base in aqueous solution. So you all know many examples. The most common one is sodium hydroxide. So I will take that as the example. What do you do? Sodium hydroxide. You have to specify it is an aqueous medium and you show the dissociation arrow towards one side and the products will be Na plus aqueous and OH minus aqueous. Then the next one. Write 3 examples of strong bases with their chemical formulae. So we have to write the name as well as the chemical formulae. So I will say sodium hydroxide, that is NaOH. What else can you write? We can say potassium hydroxide, potassium hydroxide, that is KOH, and also we can have calcium hydroxide. That is CaOH twice. So sodium hydroxide, potassium hydroxide and calcium hydroxide. So those are the answers for these questions. So what is a strong base? A substance that dissociates completely and increases the hydroxyl ion concentration. It should have been the hydroxyl ion concentration. The hydroxyl ion concentration of the medium. Write the equation for the dissociation of a strong base in aqueous solutions. Sodium hydroxide aqueous becomes Na plus aqueous and OH minus aqueous. And write 3 examples of strong bases with their chemical formulae. Sodium hydroxide NaOH, potassium hydroxide KOH, and calcium hydroxide CaOH twice. With that, I will move on to the next question. Extra question 8. What is a weak base? Similar to the previous one, you can say a substance that dissociates partially. Here it is partial dissociation. Partially and increases the hydroxyl ion concentration of the medium. So here the only difference is it dissociates partially or incompletely, you can say. Write examples for weak bases. You all know examples of weak bases. What are they? Ammonia gas or ammonium hydroxide solution. Both are the same compounds but in different forms. Ammonia is in the gaseous state. When it dissolves, it forms the ammonium hydroxide solution. So that is actually one example, and you can also write magnesium hydroxide. So here I will say ammonia gas or ammonium hydroxide. Then we can say magnesium hydroxide. Here, of course, students, you don't have to write the chemical formulae because they have only asked for examples, but you can either give it in words or you can write the chemical formulae also. Either way, it's fine. With that, I will move on to the next question. Extra question 9. Write the properties of bases. What are the properties of bases? They have a slimy nature. When they dissolve in water, they have a slimy nature. And usually the bases are solids at room temperature. What else can you say? They turn the red litmus to blue. So those are the properties of bases. We can write them down here. Bases have a slimy texture. I will write short answers. Slimy texture. Then they are solids at room temperature. Room temperature. And also they turn red litmus to blue. If you like, you can also say the pH of bases is greater than 7. It's from 8 to 40. That is also a property. But here, since they have asked, they haven't mentioned any number, so I'll just stick to these three. Slimy texture, solids at room temperature, and they turn red litmus to blue. Then what are alkalis or alkaline solution? I have told you all. What are they? Bases that dissolve very well in water and form aqueous solutions. So bases that dissolve well in water are known as alkalis. Write examples of alkalis. Here we can say sodium hydroxide aqueous and potassium hydroxide aqueous. Here also you can write the names. I have written the chemical formulae. You can write the name. Sodium hydroxide solution, potassium hydroxide solution. So those are examples of alkalis. With that, I will move on to the next one. Extra question 10. Write 2 uses of the base magnesium hydroxide. What are the uses of magnesium hydroxide? It's used as milk of magnesia and also to purify molasses. So those are the uses of magnesium hydroxide. Used in milk of magnesia. Or you can even say as an antacid suspension. anything is fine. Then for purification of molasses. Purification of molasses. So, two uses of magnesium hydroxide. Then the next one, extra question 11. The indicators given below can be used to identify acids and bases. Complete the table. So, the indicators are given litmus, phenolphthalein and methyl orange. You need to write the acid color and the base color. What is the acid color of litmus? It is red. And base color? Blue. Why? Acids turn blue litmus to red and red litmus remain the same. And bases turn the red litmus to blue, blue litmus remains the same. So, the acid color of litmus is red, base color of litmus is blue. Then we have phenolphthalein. What is the acid color? It's colorless, same as the indicator, colorless. And what is the base color? It is pink. These are all the observations that you got from the activity as well. So, you know what they are. Then what about methyl orange? Methyl orange gives red color with acids and yellow color with bases. Did you all write them correctly? I am sure you did. With that, I will move on to the next one. Extra question 12. Write the observations when the given indicators are added to the solutions given in the table above. So, here you are given the table. Solutions are given. Here again litmus, red and blue, methyl orange and phenolphthalein are given. So, for dilute hydrochloric acid, what are the colors? Red in color. With methyl orange, again red, and phenolphthalein, it will be colorless. So, you all can remember students, I did this activity in the lab. You all were able to see all the observations clearly. So, you know the colors. Lime juice again, litmus is red, methyl orange red, and phenolphthalein colorless. Dilute sulfuric acid, all are acid, so the same observation. Red for litmus, red with methyl orange and colorless with phenolphthalein. Vinegar, same thing. Red with litmus, methyl orange also red and phenolphthalein colorless. Then how about dilute sodium hydroxide? The litmus color is blue because it turns red litmus to blue. And with methyl orange, the color is yellow. And with phenolphthalein, the color is pink. Soap solution, that is also a base. So, the same colors you have observed before, blue for litmus, yellow color with methyl orange and pink color with phenolphthalein. Pink color with phenolphthalein. So, I am sure you were able to fill this correctly. Why? Because you can remember the colors that you saw when we did the activity. With that, I will move on to the next one. Extra question 13. Identification of acids and bases by indicators is not a very accurate method. Why? Because you cannot identify whether it's a strong acid or a weak acid, strong base or a weak base. Therefore, the pH scale is used to indicate how acidic or basic a given solution is. The scale generally consists of a series of numbers from 0 to 14. Each number corresponds to a color. Study the pH scale given below and answer the questions. So, here the pH scale is given to you. You can see all the colors. You know the acidic range. 7 is neutral and from 8 to 14 it's the base. And you know the acidity decreases, basicity increases when you go from 0 to 14. Now we will look at the questions. Write the pH range of the substances given below. So we need to write the pH ranges of the substances given below. What is the first one? Distilled water. Distilled water is neutral. So what should be the pH? It should be pH 7. So here pH is equal to 7. So what is acidic substances? From 0 to 6. pH 0 to 6. Then how about basic substances? pH next to 7 is 8 to 14. So we have the range 0 to 6 is acidic. Then we have 7, that is neutral substance. 8 to 14 is basic. Then the next one. When the values change from 0 to 6, what happens to the acidic nature of substances? Acidic nature decreases, or you can say acidity decreases. Acidic nature, or you can say acidity decreases when you go from 0 to 6. 0 is the strongest acid, 6 is the weak acid. When the value change from 8 to 14, what happens to the basic nature of substance? What happens there? Basic nature increases. Basic nature increases. So that is how we compare the nature of acids and bases. With that, I will move on to the next question. Extra question 14. How are salts formed? How do they form? During the reaction between an acid and a base. So here we can say during the acid base, you can include the name neutralization reaction. Neutralization reaction, or you can just say acid-base reaction. Then write examples of salts that are used in day-to-day life. Write equations to show how they are formed. So here, if you write equations, now we can take one example, the common salt, sodium chloride. Write examples of salts that are used in day-to-day life. So common salt, how is that formed? A reaction between hydrochloric acid and sodium hydroxide. Then only we will get NaCl and H2O. So what are the other salts you can think of? Sodium carbonate. So sodium carbonate is washing soda. Now we can write sodium carbonate. Now how can this form? Sodium has to come from a base. So it has to be sodium hydroxide. And how about carbonate? That can be obtained from carbonic acid. You can remember that. H2CO3. So that will give you Na2CO3, sodium carbonate. So those are examples of salts. Write examples of salts that are used in day-to-day life. Write equations to show how they are formed. What else can you think of? You can even write sodium bicarbonate. That also forms during a reaction between sodium hydroxide and carbonic acid, but in a different way. So you can also write the equation, students, where you write calcium bicarbonate. When we test for carbon dioxide. When you bubble carbon dioxide to calcium hydroxide, lime water, we get calcium carbonate. So that is also a basic salt. So here you can write that as well. I have written 2 examples that are most commonly used. With that, I will move on to the next question. Extra question 15. Write the properties of salts. What can you say? Properties of salt. They are crystalline in nature. They are usually solids at room temperature. They have a high melting and boiling point. And also they dissolve, most of the salts dissolve well in water. So if we write the properties, crystalline, then solids at room temperature, most salts dissolve well in water and also high melting point and boiling point. So those are properties of salts. Then write 2 uses of the salts NaCl and copper sulfate. So for what can you use sodium chloride? Sodium chloride, that is NaCl, the common salt. Added to food as an additive. Added to food during preparation. What else? In preserving food. So, food preservation. What else can you write? Glazing of earthenware, tanning of substances. Like that you can write any 2 uses of sodium chloride. Then for copper sulfate. Copper sulfate. What can you write for copper sulfate? Used as a fungicide in agriculture. Fungicide in agriculture. What else can you write? You can say used commonly in laboratories, then used for electroplating, used for electroplating, copper plating of substances, used in production of paint. Like that you can write any use here. So sodium chloride as well as copper sulfate, they have asked for 2 uses. Then with that I will move on to the next one. Extra question 16. What is neutralization? What is neutralization? Formation of water by the combination of H plus ions with OH minus ions. So if we write neutralization, formation of water by the combination of H plus ions with OH minus ions. When during acid-base reactions. So, formation of H2O by the combination of H plus ions with OH minus ions during acid-base reaction. That is what we call as neutralization. That's why the acid-base reaction is known as neutralization. Write an equation for neutralization. You can write any. Let's say I will write the neutralization between potassium hydroxide aqueous and sulfuric acid aqueous. You will get K2SO4 aqueous plus water liquid. We have to make sure that the equation is balanced. We have to balance it by writing 2 here and a 2 there. So, 2 potassium hydroxide aqueous plus sulfuric acid gives rise to K2SO4 aqueous, that is potassium sulphate, and 2 water molecules. That is an example. You can write any sodium hydroxide and hydrochloric acid, sodium hydroxide and sulfuric acid, nitric acid and potassium hydroxide between any acid and a base. Then the next one. Write 2 applications of neutralization. What are the applications of neutralization? For acidity, we use a mild base as the antacid tablet or milk of magnesia, where the hydrochloric acid in the stomach gets neutralized by the magnesium hydroxide present in milk of magnesia. So, that is one application. Using a weak base as an antacid tablet to relieve acidity. Example, magnesium hydroxide in milk of magnesia. What else can you say? Ash is used to reduce acidity of soil. You can write that as well. I will write the second one. Ash or even lime is used to reduce or neutralize acidity of soil. What else can you say? Bee sting. Bee sting is painful because of the acidic poison. So, we can use a basic substance such as baking powder or slake lime that is available at home in order to relieve the pain. The same way, wasp sting is a basic substance. And to relieve the pain from wasp sting, we can use either lime juice, tamarind, or any citrus substance. Those are acidic. So, like that, we can use this neutralization reaction in our day-to-day life. Write 2 applications of neutralization. So, I am sure you were able to answer all these questions as well. So, with that, I will move on to the next one. Extra question 17, fill in the blanks. Acidic substances change the color of litmus to what? Acidic substances change the color of blue litmus to red. Then basic substances change the color of red litmus to blue. Then the third one, a solution is obtained when ammonia gas is dissolved in water. A basic solution. A basic solution is obtained when ammonia gas is dissolved in water. The next one, gases evolve when hydrochloric acid reacts with calcium carbonate. The reaction of hydrochloric acid with calcium carbonate, what is it? You all can write and check if you want. HCl plus calcium carbonate will give you calcium chloride plus CO2 plus water. You know, students, acid reacts with carbonates and bicarbonates to release carbon dioxide. You can remember that. If not, you can write the equation and fill in the blanks. So, carbon dioxide gas. Carbon dioxide gas is evolved when hydrochloric acid reacts with calcium carbonate. Last one, gases evolve when hydrochloric acid reacts with magnesium. That also you can write the reaction. HCl and magnesium, it will give you magnesium chloride plus H2 gas. So what is the gas? Hydrogen gas. Hydrogen gas. Acidic substances change the color of blue litmus to red. Basic substances change the color of red litmus to blue. A basic solution is obtained when ammonia gas is dissolved in water. Carbon dioxide gas is evolved when hydrochloric acid reacts with calcium carbonate. And hydrogen gas is evolved when hydrochloric acid reacts with magnesium. With that, I will move on to the next one. Extra question 18. Mark the sentences given below as correct or false. Salt and water are produced when an acid reacts with a base. That is correct. That is the neutralization reaction. Sulfuric acid is used in the paper industry. Is it sulfuric acid? No, it's acetic acid. So that is false. Then sodium hydroxide is used in refining petroleum products. That is of course correct. That is one use of sodium hydroxide. Milk of magnesia contains MgOH. Is that correct? No, it has to be MgOH twice, magnesium hydroxide. You all can remember the valencies, you know to write chemical formulae. So this is false. And acids have pH values above 7. No, they have pH values below 7. So that is also wrong. So I am sure you were able to get them correctly. Salt and water are produced when an acid reacts with a base. That is correct. Sulfuric acid is used in the paper industry. That's wrong. Sodium hydroxide is used in refining petroleum products. That's correct. Milk of magnesia contains magnesium hydroxide. Their MgOH is wrong. And acids have pH values above 7. That is also wrong. With that, I will move on to the next one. Extra question 19. Write one use for each of the substances given below. Sodium hydroxide. One use of sodium hydroxide. We can say production of soap. Production of. You can write any use. Sodium hydroxide is used in the refining of petroleum products, production of soap, like that you can write any application. I have written production of soap. Then magnesium hydroxide. There are two main uses, purification of molasses and milk of magnesia. I will say milk of magnesia. Milk of magnesia. I am writing short answers here. Acetic acid. Acetic acid is present in vinegar. Acetic acid is used in paper industry. So like that, you can even to coagulate rubber, we can use acetic acid. So here I will say vinegar. Then sulfuric acid. One use of sulfuric acid. That is again used as a dehydrating agent. It is used as battery acid. So like that, we can write any example production of fertilizers. So like that, you can write anything for sulfuric acid. Here I will say battery acid. Battery acid. Then what about copper sulfate? For copper sulfate, again copper sulfate is used in the laboratory for electroplating, then as a fungicide. You can write any one. So for copper sulfate, I'll say electroplating of copper. Of copper. Then sodium chloride, that also you know. Glazing earthenware, tanning of substances, used as common salt in preparation of food, food preservation. There are many uses. So sodium chloride, I will say food preservation. So students, these are things that you use in your day-to-day life. So you're familiar with those. If not, at least in the lab we use them or in an industrial process. So it's easy to remember. So I'm sure you were able to write all these correctly. You could have even written other uses as well. So with that, I will move on to the last question, extra question 20. Write the acid and base that react to form the salts given below. So the acid and the base. So here sodium chloride is produced from hydrochloric acid and sodium hydroxide aqueous. How about magnesium nitrate? The nitrate comes from nitric acid, HNO3 aqueous, and magnesium is from magnesium hydroxide. How about calcium carbonate? Calcium hydroxide. So here acid and base, so it has to be carbonic acid first, H2CO3, and here it has to be calcium hydroxide. Then magnesium sulfate from sulfuric acid and magnesium hydroxide. Then how about aluminium sulfate? Aluminium sulfate again from sulfuric acid and aluminium hydroxide. Al aluminium hydroxide. So those are the acids and bases that form this salt. Hydrochloric acid and sodium hydroxide, sodium chloride. Nitric acid and magnesium hydroxide, magnesium nitrate. Carbonic acid and calcium hydroxide, calcium carbonate. Sulfuric acid and magnesium hydroxide, magnesium sulfate, and sulfuric acid and aluminium hydroxide, aluminium sulfate. So students, with that, I have completed the extra questions as well. So we discussed the acid, bases and salts, how they are formed, what they are, how they react and their properties as well as their uses. Then I discussed the questions in your textbook and the extra questions. So with that, when you keep on practicing, you will become competent to answer any type of